for this first demo, I'm going to show you this in action. And I need to stop this real quick. Let a little garbage cleanup happen. This is my C drive, and as you can see, I killed that window, and a big blob of storage just went away. One thing to keep in mind with a buffer pool SSD is that when you create it, the syntax is actually pretty easy. You can do this on the fly. As you can see, here's the syntax right now. All we have to do is alter our server configuration. Now, my S drive on this VM is specifically created on my SSD. You could create a buffer pool extension on a non-SSD. There's nothing under the covers that actually currently goes and checks that the mechanical hardware has registered bits as an SSD. But you wouldn't necessarily want to do that just because flushing your buffer pool at the disk is going to be like taking hard page faults. That's not something that you're going to want to invite. After we would configure our buffer pool extension, we actually alter the state and we set it to on. If you wanted to turn this off and reclaim this, in order to resize a buffer pool extension, you would actually set this to off. You would drop it, and then you would add a new one with a new size specification. I put 8 gigs of physical RAM on this VM, and then what I did was I added a 15 gig buffer pool extension, and then I took my max memory configuration and I put it up to 19 gigabytes. Now the tough thing about this is we've got to actually peg the memory before we're going to start falling over into our buffer pool extensions, because it's always going to be quicker to use actual in-memory processes. So the big thing to keep in mind is the SSD is not a replacement for using RAM. And you should never look at it like that. It's just an extension. If for some reason maybe you've exceeded the number of RAM chips that you can put in a slot, for some reason the guy in your server room is really big on buying SSDs but not so big on buying more RAM, not sure why, but if that's the case, then you definitely want to use this to extend your buffer pool. But that's the thing to keep in mind, is it's not going to fall over to a buffer pool extension until the point that we get where we've actually utilized all of our memory. So here's some different databases that I've got on this particular instance. What I'm doing is I'm taking system OS buffer descriptors, and they've added this nice little bit flag, is in buffer pool extension for 2014. I've got a nice case statement on here just so I can see the data that is actually on my system and see where it is allocated. And as you can see, right now for my AdventureWorks Data Warehouse 2013, I've got about 4 gigabytes that's actually taking up non-cached memory. For my ColumnStore, I've got about 900 megs that's currently in my buffer pool extensions. And then for my AdventureWorks Data Warehouse, I've got 206 megs that are stored in my BPE. And you can see that some of my other smaller databases, it looks like their cache was probably pushed over there as well. If I do a really big query against a table, and remember, I need a result set so big that it's going to exceed the physical amount of RAM that I've got on my server, eventually it will push things into using a buffer pool extension. I've got a script that you can download that are going to be in the demos for that's called Make AdventureWorks Data Warehouse Big. And what I do is I take the fact internet cells and I make a fact internet cells big table. The one in this particular demo has a little over 40 million rows in it. And let me pull up Summit for you guys real quick. Has a little over 42 million rows, and you can see it's taking up about 8 gigabytes worth of data. And that's the thing, is I really had to stretch to be able to create a table large enough that I could actually exceed the memory that I had given to this particular VM. And as you can see, the memory is pretty capped out at the moment. I'm currently using 81%. The nice thing is, it will actually leave a bit of a buffer in place, which is good for our operating system, because that's one of the biggest problems that we've had with our max memory in the past. is if people don't set max memory on their server, it can grab a lot of the system memory, and then your operating system and your SQL Server end up in a tug-of-war. The nice thing is, even though I've begun to use my buffer pool extensions, I've still got a nice gap there that allows some of my physical memory to be utilized by the operating system. And that was the point in time, you can see right about here, where my BP stepped in and actually started taking the data that was going to be paged into memory. So next up, we've got in-memory OLTP. This is the artist formerly known as Hekaton. Data is stored in memory, and it's really interesting because for the first time ever in SQL Server, you can choose to follow ACID or not. You can have non-log tables in Hekaton. That's really exciting. There are some data type limitations. There's actually a whole list of limitations right now in the CTP. Expect that to get rolled back before we actually get to RTM. Because in its current state, there's not a lot that we can do to play around with it. But like I said, that's going to change. The exciting part about non-log tables is that if you think about something like a staging table for a data warehouse, you never really want to log those tables because you normally load them, truncate, push them out. It's a very exciting idea that we can actually take tables like that, put them into memory, just utilize hash values, insert data on the fly, ETL that data out, and then truncate those tables, and we don't need anything stored within them. And we can actually get away from write-ahead logging in that case. That's very exciting. We've also got in-memory compiled store procedures. They're also called natively compiled store procedures. The natively compiled store procedures basically get compiled down to the machine code, so there's less work to actually get these procedures to execute. They are very efficient when it comes to CPU. I've seen boxes where Hekaton was running, where we had about 10,000 transactions a second utilizing regular stored procs on Hekaton tables. By using natively compiled store procedures, our CPU was pegged at around 70 to 80%. By using natively compiled stored procs, we were able to increase the throughput to about 12,000 transactions per second,